So, if you come across this problem in the 2026 QAMT Problem Solving Competition, what are you going to do? Joe chooses three distinct vertices at random from a regular hexagon of area 6. What is the probability that the area of the triangle determined by Joe's chosen vertices is larger than 1? Okay, now, a regular hexagon with area 6, right? If the area of this is 6, I'm able to chop it up into 6 equilateral triangles, and their area are all going to be 1, right? So we're going to base that off of that. So, how many ways are there to choose 6? If we choose 3 consecutive vertices, this triangle here, what is the area of that? Well, if we consider chopping this up, we can see that all 6 of these triangles have the same area, and that's also going to be 1. So the area of this triangle here is 1, because it's 1/6 of the regular hexagon. What happens if we choose 2 consecutive vertices, but then we don't choose another consecutive vertex? Then we have to choose one of the other vertices, and it's basically the same just by a reflection. So what's the area of this? Well, we can see that this is going to be a right angle. And I can draw a line there. The area of this is the same, it's the same shape as this one here. So the area of this is 1 and 1. So the area of the whole thing is 2. Now, we've taken care of all the cases if we choose 2 consecutive vertices. So what happens if we never choose 2 consecutive vertices? We have to take this configuration. And of course, we can see that here, that all of these have area 1. So the area of this triangle is going to be 3. Now, how many ways are there to choose 3 vertices? We need to calculate what's the probability of getting each case. So how many ways are there? So total number of ways of choosing 3 vertices out of 6. That's 6 choose 3. And I can write this as 6 times 5 times 4 over 1 times 2 times 3. That's 1 times 2 times 3 cancels with the 6, 5 times 4. There's 20 different ways of choosing 3 vertices. In area 1, we have to choose 3 consecutive vertices, right? And this can be rotated across the hexagon. So there's 6 ways. And what happens if the area is 2? Of course, this can be rotated around the hexagon in 6 different ways. But instead of this, we can move that vertex here. Something like this is also going to have area 2. So that means there's what? There's 2 times 6. There's 12 different ways of getting something with area 2. The area is 3. There's only 2 different possibilities. Apart from this one, the only possible thing we can do is this one. There's only 2 possibilities. And you can double check that the sum of these is 20, which matches with that. So we can be sure that we have the right answer here. So now what is the probability that we want? The probability that the area of the triangle is larger than 1. So if it's larger than 1, it has to be either 2 or 3. So it's 12 plus 2 over 20. So there's 14 of the 20 possibilities is going to be larger than 1. So 7 over 10 or 70%. So this is going to be your final answer. And we are done.